The main emphasis of this course will be the study of motion. So in this course, we're going to learn why objects move as they do. We're going to learn why an object will start to move, why an object will stop moving, why it will get faster, why it will get slower, why it will turn left, why it will turn right. So we're going to start here with a demo which will help us lay down the first basic principle we need in order to understand why objects move as they do. Now, what I have here is called an air puck. If I simply set it on the table, then it's just going to sit there. Or if I push it, you can see it will start moving, but then slow down because of friction between the air puck and the table. However, if I hit this little switch here, air is going to start blowing out the bottom of the air puck. And now with that air blowing out the bottom of the air puck, you're going to see it moves differently. So you can see that because of that cushion of air coming out the bottom of the air puck can glide frictionlessly along the top of the table. So we're going to start to make some simple observations about the motion of the air puck. Now, first of all, you can see that I'm not doing anything to the air puck, and at the moment it's just sitting here, right? So one thing that the air puck can do when I am not interacting with the air puck is to just sit there. Okay, now I want to look at what happens when I give the air puck a little nudge and watch it cruise along the table. Okay. So you can see there that the air puck would cruise along the table, but then when it hit the obstacle over here, it would change its direction of motion, right? I can even go for a bank shot. Sometimes I'm able to do this. Nope, not quite. Nope. Ah, there we go. Okay. Anyways, what I want you to notice there is not what happened when the air puck hit the obstacle, right? We know that when the air puck hit the obstacles, the direction of motion changed. What was the air puck doing in between hitting the obstacles? Okay. Can you see that what the air puck was doing when it wasn't hitting an obstacle was moving in a straight line at constant speed, right? Show you again. Okay. So between the time my hand released the air puck and the time it hit the obstacle over here, it was moving in a straight line at constant speed. And then after the air puck hit the obstacle, it again moved in a straight line at constant speed until it got to the edge of the table. So we've seen here that there are two things the air puck can do when it is not interacting with other things. One thing the air puck can do when it's not interacting with something else is to simply sit there motionless. The other thing an air puck can do when it is not interacting with something else is to move in a straight line at constant speed. Those two things. Okay? Now, this actually goes for any object. With any object at all, there are only two things it can do when it is not interacting with another object. One, not move at all. And two, move in a straight line at constant speed. So I'm going to write all that out on the board, and then we'll talk about that a little more. Okay? So an object not interacting with other objects can either sit still, not move at all, or move in a straight line at constant speed. Okay, now, if you look at this, can an object which is not interacting with other objects get faster or slower? Well, if an object is sitting still, is it getting faster or slower? No. If an object is moving in a straight line at constant speed, is it getting faster or slower? No. So an object which is not interacting with other objects does not get faster or slower. Okay? Can an object which is not interacting with other objects change its direction of motion, like turn left or turn right, for example? Well, if an object is sitting still, is it turning left or right, changing its direction of motion? No. If an object is moving in a straight line at constant speed, is it changing its direction of motion? No. So An object which is not interacting with other objects is not changing its direction of motion. Okay, so to sum up, an object which is not interacting with other objects cannot get faster or slower. An object not interacting with other objects cannot change its direction of motion. So the next question would be, what must happen in order for an object to either change its speed, get faster or slower, or to change its direction of motion? So think about that. We will pick it up in the next video.